pump handling 100,000 kilograms per hour flow of water coming from an atmospheric storage tank, right? Okay, the water temperature is 25 degrees Celsius, right? And the suction line of the pump is 6-inch diameter and 20 meter in length, right? So that is the problem. The suction nozzle of the pump is 0.4 meters. Be very careful about this information, right? The suction nozzle of the pump is 0.4 meters above the ground level. The tank is elevated on a 1 meter high platform, right? Now this is the tank, right? Now the tank is elevated means now where the tank is actually kept, right? The tank is elevated on a 1 meter high platform. That means, right, the height, right, to the base surface where the tank is kept, right, the distance between the base surface and the respected ground level is what is that, 1 meters, right? So be very careful about the given dimensions, right? Tank is elevated on a 1 meter high platform. So now this is like the platform, right? Some sort of a, let's say some sort of a platform is there, right? Some sort of a platform. Okay, so no problem. So 1 meters from the ground, right? Okay, the minimum liquid level of the tank is 300 millimeters. That means what is this length? That means the liquid level, right, of the tank is 300 millimeters. This level, right, here to here, 300 millimeters, right? Okay, fine. So now we have to calculate the net positive suction head rate. Okay, so now let's see. Now for that there is a particular equation, right? Net positive suction head equals, right? So let's focus the equation, right? So that is P naught minus PV divided by rho G plus delta Z, right, minus head loss. That means H loss, right? P naught minus PV divided by rho G plus delta Z minus head loss, right? So now let's see, right, what is P naught? What is P naught? P naught is water pressure at the top surface, right? Now see, it is, now what sort of a storage tank is this, right? Atmospheric storage tank, right? What is that? Atmospheric storage tank, right? So what is P naught? So then P naught is actually top surface pressure, right? Top surface pressure of water, right? Top surface pressure of water, right? So that is P naught, right? So then what is PV? That is the saturation vapor pressure of water, right? What is PV? This one, this PV is the saturation vapor pressure of water at what temperature? Saturation water temperature. Saturation. What is PV? That is the take again, right? So what is PV? So that is the saturation vapor pressure of water at 25 degrees Celsius. Right? Saturation vapor pressure of water at 25 degrees Celsius, right? So that is also done. Rho, you know what is this rho? I will tell that also. Water density, right? G, acceleration due to gravity. G is actually acceleration due to gravity. What is that? 9.81 meters per second square, right? Okay. Rho is the density of water, right? But here you have to consider the density of water at 25 degrees Celsius, right? So that is very important, right? It's okay, you can even consider, like, according to the general format, you can consider as 1000 also, but here in the question it is given, right? So here in this problem actually the density of water is given as 994, yeah, 994.72 kilograms per meter cube, right? Okay, what is P naught? P naught is at atmospheric pressure. What is P naught? That is the atmospheric pressure. What is atmospheric pressure? It is 1 atm. So what is 1 atm? 1 atm is not 1 bar. Okay, be very careful about the conversion. It is not 1 bar. It is 1.01325 bar. Right. Okay. 1.01325 bar. Right. Okay. Because it is not the same, right? But be very careful. Units you have to keep in the standard format, right? Okay, but if you are going to consider the units, you have to keep the units in the standard format, right? So 1.01325 bar means, if you are going to consider that in pascals, it will be 1.01325 into 10 to the power 5 pascals, right? Okay. And what is PV? What is PV? PV? What is PV? PV is the saturation vapor pressure of water at 25 degrees Celsius. What is the saturation vapor pressure of water at 25 degrees Celsius? So that you can actually find from the internet or from the chart, okay? So that is 0.032 bar. What is that? 0.032 bar. So that means it is 0.032 multiplied by 10 to the power 5 pascals, right? 0.032 multiplied by 10 to the power 5 pascal, right? Okay. So what is delta Z? What is delta Z? Now delta Z is the height difference. Now be very careful. What is delta Z? Is the height difference between the nozzle. So now in this problem it actually describes a nozzle. So now let's go for that. What is that? Now see. The suction nozzle, be very careful. What is that? The suction nozzle of the pump is 0.4 meters above the ground level. The suction nozzle of the pump. Now this is the suction nozzle of the pump, right? So that is actually, that means this side, the height from the ground to the suction nozzle. So that is 0.4 meters. Ground to the height between ground to the suction nozzle. So that is it, right? So now what is actually, so then what is delta Z? So now delta Z is the difference, right? Delta Z is the difference, the height difference between the suction nozzle and the water top surface, right? So that means this distance, the height difference between the suction nozzle and the water top surface, or the top surface of water. So what is delta Z then? So then delta Z equals, be very careful, now I am teaching you how to find delta Z. Delta Z equals, right? Be very practical, right? First, the distance, the height difference, or the distance from ground to the base where the tank is kept, right? Distance from base to where the tank is kept. Okay, so that is one. And then from the base to the water surface height. From the base to the water surface. So what is the distance from the base to the water surface? That is also given in the problem. 300 millimeters means 0.3. So 1 plus 0.3. Right. Okay. Then from that you have to deduct the distance from ground to the suction nozzle. So what is the distance from ground to the suction nozzle? That is 0.4. Right. So that minus 0.4. So that will give you the value for delta Z as 0.9 meter. So this is known, this and this also known. So now what is the next thing that we need to calculate, right? So now like almost all the things are now we have actually found, right? So now we have to calculate the head loss, because now if you are going to consider the pipes, right, so there is a kind of a head loss, right, that will take place, right? So how to evaluate the head loss, right? So now for head loss also there is a formula. Head loss is calculated in such a way, right? Head loss equals frictional, right, pressure loss per 1 kilometer, right? So what is head loss? That is frictional pressure loss per 1 kilometer in the suction line. Be very careful, in the suction line, right? Frictional pressure loss per 1 kilometer in the suction line multiplied by what? Length of the pipe, right? Length of the pipe, right? So now actually in this question, let's consider this is given, right? Other than that, that also you have to find from the chart, right? Because now the diameter is given, flow rate is given, right? So if you consider a frictional pressure loss per 1 kilometer in the suction line is given, so that is given as 1.3, right? 1.3 bar of pressure loss per 1 kilometer, right? 1.3 bar of pressure loss per 1 kilometer, right? So what is the length of the pipe? Oh, length of the pipe is 20 meters, right? So length of the pipe is 20 meters. So 20 meters meaning this 1.3 you have to multiply by what? 0.02 kilometers, right? Because now pressure loss is given for like kilometers, right? So 1.3 bar per kilometer, right? So now the line length of the pipe is 20 meters, so that means 0.02 kilometers, right? So then you can get the pressure loss. So 1.3 multiplied by 0.02, right? So we know that 13 multiplied by 2 is what? That is 26, right? So how many decimals that we have to consider? See, 1, 2, 3, right? So take 1 from here, take 1, 2, 3. That means the answer is 0.026 bar, right? It is what? 0.026 bar of head loss, right? 0.026 bar of head loss, right? So now the next thing, now this head loss, right? That means actually this loss is actually that is accounted in bars, right? But we have to convert that into a length, right? So we know that pressure equals H rho G, right? So now we have to consider it as a head loss. That means H, something like height, right? So head loss equals what? P divided by rho G. Now pressure, you know what is the pressure? 0.026. Be very careful, bar, right? So the units must be the standard units, right? So you have to multiply 0.026 bar by 10 to the power 5, and that will give you the answer in Pascal. So that is divided by rho G. Rho, you know, 994.72 multiplied by G is 9.81. So take your calculators and find the answer. I also use my calculator. 0.026 into 10 to the power 5 divided by 994.72 and divided by 9.81. 0.266 0.266 meters. So let's consider as 0.27 meters. Right, 0.27 meters, right? So that means now all the things are evaluated, right? And now we have completed that, right? Right. So again, let's write the formula. So now what is the formula? Net positive suction head equals P naught minus P vapor divided by rho G plus what? delta Z minus head loss, right? We have to multiply by 9.81 also, right? See G is there, acceleration due to gravity, right? So then this answer, that answer positive 0.9 minus the head loss, minus 0.27 of head loss. The answer is 10.685. 10.685. The answer in the, what will be the units? Meters, right?